All right, guys. So we are going to answer one more question on the partition coefficient. And I know that we are okay with partition coefficient generally. Now we have this question that says, a pharmaceutical analysis was carried out to evaluate the distribution of substance P with a molecular formula of 6,6H6O2. Now from there, from what you can see here, this molecular formula actually is the molecular formula for benzoic acid, right? So 2.5 gram of substance P was dissolved in 50 ml of water. I was extracted with 50 ml. That means this 2.5 gram was dissolved in 50 ml of water. I was extracted with 50 ml. That is in batch. Yes, what is called batch extraction in liquid or solvent extraction. Now this partition coefficient is also called liquid extraction or solvent extraction. Yes, what is called batch extraction, whereby you extract with the liquid in one quantity, then you use another quantity again and another quantity again. Are you getting it? That is what is called batch extraction. I believe that we are going to do more on liquid extraction second semester. So we have 20 ml, 10 ml, but everything at the end of the day will still go into one, the extract. That means what you got from 20 ml, and 10 ml will still go into one container. Are you getting it now? The only thing you did was that you extracted more than once. That means all the organic phase will still go into one container. It means what you got by extracting from 20 ml will come here, that of the other 20 ml will come here, and that of the other 10 ml will also come here. In total, how many ml did you extract with? You extracted with about 50 ml. Are you getting it now? So instead of using 50 ml at once, you actually did it. First of all, it's more like where you are missing something. Then you want to use 50 ml of water. You first of all use, let's say, 20 ml to remove some. Then you add another 10 ml to rinse it and add another 20 ml to finish rinsing it again. That's exactly what this is of chloroform. Chloroform is the organic phase, while water is the aqueous phase. Now I say 5 ml of chloroform. That means 5 ml from this 50 ml, which was extracted in batch, 20 ml, and 10 ml. 5 ml of the chloroform extract were placed in a conical flask. You took 5 ml from the total amount here, and then placed it in a conical flask, and 2 drops of phenolphthalein added and titrated with 0.1 molar sodium hydroxide from a burette until the color changes to pink and the titer value obtained here. Now, listen. From this question, you cannot actually choose the amount in the aqueous phase and that in the what? In the organic phase, because it was not stated explicitly. However, when I saw the material, I saw them write something on top of this thing here. So definitely one is the organic, one is the aqueous. So I'm going to use this as the organic phase. That means the titer value from organic phase, and this is the titer value from aqueous phase. Because I told you that in most cases, the titer value from the organic phase must be higher than the titer value from the aqueous phase. Somehow, it should be higher from some understanding. Now, the first thing is write the balanced equation of reaction and calculate the Milli equivalent. Now, for you to calculate the Milli equivalent, there are certain things that you must take note of. First of all, the molecular mass. The molecular formula was given as C7H6O2 first, and then the amount of sodium hydroxide that was reacted. You reacted with what? 0.1 molar sodium hydroxide. So these are the two properties that will aid you in writing the Milli equivalent, because some persons are still finding it difficult to write Milli equivalent. Now, if you know these two things, you are now going to come here and write the equation of reaction. So the first thing says write the equation of reaction and then calculate the Milli equivalent. So to write the equation of reaction, what I'm going to do is to come here and then we are going to start writing the equation of reaction. The equation of reaction usually starts with the benzoic acid, because that formula of C7H6O2 is benzoic acid. If you see it, how many carbons are here? 1, 2, 3, 4, 5, 6, plus this one 7. Then how many hydrogen? Each of these will have one hydrogen. 1, 2, 3, 4, 5. then plus this one 6, then 2 oxygen. This is C7H6O2, which is benzoic acid. Now when you react benzoic acid plus sodium hydroxide, according to what we said from the equation of reaction, what are we expected to get? We are supposed to get sodium benzoate, all right, which is this, plus what? Water. This is an acid plus base to give us salt and water. So you can come here and label everything that we'll have here. So here is benzoic acid plus what? Sodium hydroxide, which is your base, plus what? So this will give us sodium benzoate, and then this will give us water. Exactly. Now this is the equation of reaction. Have you written the equation of reaction now is to calculate the milli equivalent. Now from what we learned in our previous class, we said the molecular mass of benzoic acid is 122, which of course we got from carbon is 12. 12 times 7. Carbon is 12. So we have 12 times 7 plus hydrogen is 1 times 6. Oxygen is 16 times 2. That will give us the molecular weight of benzoic acid. 12 times 7 is 84 plus 1 times 6 is 6 plus 16 times 2 is 32. 84 plus 6 will give us 90. 90 plus 32 will give us what? 122 gram. So the mass of benzoic acid is 122 gram. How many moles of sodium hydroxide was reacted? 1 mole of sodium hydroxide. How many moles of benzoic acid? 1 mole of benzoic acid. Are you getting it now? So these are the two things you are going to use to write the milli equivalent. Now remember that the concentration of sodium hydroxide that reacted given in the question was 0.1 mole. Are you getting it now? The amount of sodium hydroxide that actually reacted was 0.1 mole. You are also going to take this into cognizance. So writing the equation of the milli equivalent, how to get the milli equivalent, we are now going to say that 122 gram of C7H6O2 gave 1 mole, or it reacted with 1 mole of what? Sodium hydroxide. But I told you that this 1 mole, you can actually convert it to other concentration, because we say molarity is what? Number of moles over volume, right? Now this 1 mole you have here is your number of moles you have here. Are you getting it now? 1 mole means number of moles. So we can say number of moles is equal to molarity times volume. Now our number of moles is 1. It means our number of moles is 1. So I can say N is 1. Now that means the molarity you are going to have must be, molarity times volume you are going to have must be what? 1. You know volume is always in liter. So we can say for us to have multiply these two things and the product will give us 1. You use your brain and think. The values must be 1 mole and what? Multiply by 1 liter. Are you getting it now? Because 1 times 1 is going to give us 1. Number of moles here is what? Is 1. Now had it been here is 2, you cannot decide to say 1 mole and maybe 2 liter, or 2 moles and 1 liter. Do you get the idea? So if the number of mole here is 3, we can decide to say, okay, 3 moles, 1 liter, or 1 mole, 3 liter. Depend on what was given. Is that okay? So our number of moles now will be 1 mole times what? 1 liter, which we can write as 1 mole, 1 molar solution times 1 liter is what? 1000 milliliter. Is that okay? So we are now going to come here and say 122 gram of C7H6O2 will give us 1 molar solution, are you getting it, of 1000 milliliter, right, of sodium hydroxide. 1 molar solution, 1000 milliliter sodium hydroxide. Now, how do you now calculate for your milli equivalent? You are now going to go back and look at this. The number of the molar concentration of sodium hydroxide given in the question is 0.1 molar sodium hydroxide. So you are now going to come here and divide this by 10, right? And then, because when you divide 1 divided by 10, is going to give us 0.1. And when you are divided by 10, of course, you also divide here by 10. So this will cancel this cancels this, and this is going to give us 12.2 gram of what? C7H6O2. This will give us 0.1 molar 1000 milliliter of sodium hydroxide. Now, to calculate for the milli equivalent, that means how many molar solution will be present in what gram of this will be present in 1 ml of 0.1 molar solution. So what you're going to do is to divide here by 1000 and also divide here by 1000. When this cancel this cancel this is going to give us 1 ml. So our answer would be this divided by this. So let me press that in my calculator. 12.2 divided by 1000. This will give us 0.0122 gram of C7H6O2 will be present in 0.1 molar solution, 1 ml of sodium hydroxide. So it means for every 1 ml of sodium hydroxide, or for every 1 ml of 0.1 molar sodium hydroxide, right, this is the amount of benzoic acid that will react. Do you understand? For every 1 ml of 0.1 molar sodium hydroxide, this is the amount of benzoic acid that will react. Now, your titer value will give you the total amount that will react when the base was actually used. So if this amount is what reacted for every 1 ml of 0.1 sodium hydroxide, you can now say it's very simple ratio, but to make things easy, you can just say amount in the organic phase. That means amount of benzoic acid, amount of C7H6O2 in organic phase, right? You can do it like this, should be equal to. Now, you are now going to come back to the titer value. What did I say titer value for organic phase should be? 11.8 ml. Because they say the titer values were obtained. For the organic phase, I'm going to take 11.8 ml. Alright? So you come here and say, for the organic phase, if 0.0122 gram of this reacted with 1 ml of sodium hydroxide, the organic phase is what? 11.8. You are now going to say that 11.8, let me just show you, 0.0122 gram of benzoic acid reacts with 1 ml by standard. So 11.8 ml is going to react with what? X. When you cross multiply, it will just be like this 0.0122 multiplied by 11.8 ml. True or false? True. So to get the amount that will be present, that means the amount of C7 benzoic acid that will react in this 11.8 ml of the sodium hydroxide you are using to standardize it, it will now be 0.0122 gram times the 11.8 times 11.8. Told you that ml will cancel ml, and this is going to give us, what would that give to us? 0.0122 divided by 11 point, multiplied by 11.8. That will give us 0.1439 gram. Please take note of it. You can decide to cross-check for any correction, because I haven't solved it somewhere else before. I'm just solving it for the first time, so there are tendencies that I may make some mistake, but the procedures are very, very correct. So this is the amount in the organic phase. Now the next one is amount of C7H6O2 in aqueous phase. In aqueous phase, the amount that will be present will be very easy, right? It will be this 0.0122 times the titer value for the aqueous phase is 8.2 mil. So you come here and say multiply by 8.2 mil, or you can just say 8.2, because I told you that mil, when you cross multiply here, that mil is going to cancel that. So 0.0122 times 22 times 8.2, and this will give us exactly 0.10004 gram. So this is the amount in the organic phase, and this is the amount in the what? In the aqueous phase in gram, right? Now you are now going to come here and do something very quickly: the concentration in organic phase and the concentration in aqueous phase. Now, but before you write that, you are now going to write note. It was 5 mil of both the aqueous phase. Let's just take it, because they already gave that of the organic phase, but they didn't state that of the aqueous phase. So we are going to take it that the 5 mil is both for both organic and aqueous. However, if the value differs, it means you also use the individual value that we are given, because that question is not complete on its own. But I'm just trying to make it make sense. Are you getting it? Because I can see that there were some correction they did there, but of course we are not in that exam, so we can't know. So note 5 mil of the acid was used in both organic and aqueous phase. That means you actually pipetted 5 mil of both the organic and aqueous phase, and the acid is present in both the organic and the aqueous phase, because benzoic acid is what was partitioned between the organic and the aqueous phase. So it was the 5 mil of the acid that was used. So to get the concentration of the acid in organic phase, it will be equals to amount in the organic phase is what? 0.1439 gram divided by what? 5 mil. Now when you cancel this cancel this, will give us 0.1439 divided by 5, which this is going to give us 0.02878 gram per mil. Now the next one is this in the aqueous phase. In the aqueous phase is going to be 0.10004 gram divided by 5 mil, and this we cancel this. This is going to give us 0.10004 again divided by 5, and this will give us 0.02000000. Let's just leave it here, gram per mil. So this is your partition, your concentration in the organic and the aqueous phase. Now the last thing you are expected to do here is the partition coefficient. Now what did we say is the partition coefficient? Partition coefficient is Kpc is the concentration in the organic phase divided by the concentration in the what? Aqueous phase. And this is going to give us organic phase 0.02878 gram per mole. In the aqueous phase, 0.02000 gram per mole. Now, the first thing that, of course, cancel our gram per mole, cancel gram per mole. When this divide this, it's going to give us 0.02878 divided by 0.0200, which is equals to 1.439. 1.439. So our KPC for this question is equals to 1.439. All right, and that is the correct answer to this one. It's kind of very easy, right? Exactly. Now, let's see for the next one. The next question says, how many moles of sodium hydroxide will react with substance D having a structural formula below and indicate the resultant product? Now, substance D is phthalic acid. Substance D is what we call what? Phthalic acid. So you should take note of it. It's something like this, a dicarboxylic acid of benzene. It's what we call phthalic acid. All right? Phthalic. Now, this one will definitely react with sodium hydroxide. But the question now is how many moles of sodium hydroxide, and then write the equation of reaction. Now, for every hydrogen plus that will be leaving here, you know this is H plus. For every H plus that will be leaving here, you need 1 mole of what? OH negative to neutralize it. Are you getting it now? So it means we need 1 mole of this to neutralize it, and need 1 mole of this to neutralize it. So in total, we'll be needing how many moles of sodium hydroxide? 2 moles of sodium hydroxide. So that at the end of the day, the product of this reaction will be something like this. And there you have COO, Na, COO, Na plus 2 H2O, which is aqueous. And this is what we call sodium phthalate. Are you getting it now? Sodium what? Phthalate. And 2 molecules of water. So definitely it will require how many molecules of sodium hydroxide? 2 moles of sodium hydroxide will be required to react with phthalic acid. And this is the equation of reaction. So definitely that is that for this particular question. So see how easy it is for us to get our answers immediately. Very easy, right? Exactly. So that is that. Now, if you want to use the idea of C1V1, I believe everybody should be able to do that by now. Using C1V1 is equals to C2V2 and the rest thing. If you want to use that, to still give us the same answer. CA VA all over CB VB is equals to NA over NB. You know NA over NB is what? Is 1 over 1. So it's going to give us CAVA is equals to CBVB. Concentration of the acid, you don't know it. So you can write Ca. Volume of the acid, 5 ml. Concentration of base, 0.1. Volume of base is the titer volume, which is 11.8 for the organic phase. So Ca would be equals to 0.1 times 11.8 divided by 5. If you want to use CAVA, 0.1 times 11.8 divided by 5. This will give us Ca and 0.236. Now, how about that of CB? I mean, for organic phase. This for organic. Now, how about the one for aqueous phase? Aqueous phase will still give us the same thing. Ca times 5 is equals to 0.1. The only thing that will change is the titer value to what? 8.2. So we have Ca 0.1 times 8.2 divided by 5. We have 0.1 times 8.2 divided by 5, which is equals to CA is 0.164. So if you want to calculate for the partition coefficient now, this for aqueous. Partition coefficient will be the concentration in the organic phase all over that of the aqueous phase, which is 0.236 divided by 0.164. So 0.236 divided by 0.164, which gave 1.439. 1.43, and it's synonymous to what we had here. What we had here was what? 1.4 something. If you check it, here is it. 1.439. So you see that they are the same thing, whichever way you use to solve it. So thank you very much for your time. We'll see you in the next one. Bye.